Okay, shall we get started? Ananya, am I audible?
Yes, sir.
Guys, get back to this.
Yes, sir, you're audible.
See, the button press. So let's get started. See, I think we have solved enough number of problems from third chapter. How was the test? Mostly NCERT idara. Mostly the questions were asked based on the formula which I told you. You couldn't do. Which one was hard? Is it the case with everyone? Yeah. But you didn't practice enough then. Let me check what was that tough. See, 16th one is a direct textbook problem. I did till, see, I did for sine 3x, sine 4x. All that you had to do was find sine 5x. What is the formula for sine 5x? How will you proceed first of all? Tell me. See, what are the two known formulae to you? Sine 3x and sine 3x, you know. So 5, how can you write it as a combination of these? Sine 2x plus sine 3x and then proceed, that's it. Only thing is you are expected to convert everything in terms of sign because the final expression says that everything should be in terms of sign. How many of you did this? Got the answer? Others? You just gave up casually. வராது எனக்கு மூளை இல்ல பட் ஏன் வரல what mistake did you do? Did you get your paper? Okay. You wrote it online or here? So sin 5x is equal to 5 sin x minus 20 sin cube x plus 16 sin power 5x. Okay. Let's try that and see, what is so tough about it. I'm just taking an empty slide. Okay. Let me take the slide and see what is so. Others didn't get it all. Huh? It's an insult to me. I've taught so much. One problem I taught how to think. In spite of it, you didn't do what to it. Veru formula which if I had solved, I can accept. Didn't I teach you the logic? Sin 3x plus sin 2x. Tell me what I was supposed to do. Sin 3x. Sin 3x. Day. Sulra. You solved nearly 50 to 60 problems based on the same formula. You're still searching for it. What is sin of a plus b form? Sin a? Up in a sin a cos b plus cos a sin b. Okay. Sin 3x is going to be 3 sin x minus. Okay. What is cos 2x formula? There are three. See, cos square x minus sin square x. But if you look at the equation they're expecting, everything should be in terms of sin, correct? It should be 1 minus 2 sin square x. You missed this step, huh? This I've told many times, no? Even in sin 3x derivation, we use something similar. Even in sin 3x formula, how did we derive it? Sin of 2x plus x only, no? There also you'll get cos 2x, no? But you people are not observing, that is a problem. Sin 3x, what is the formula? 3 sin x minus 4 sin cube x. But how did we derive it? Like this only, no? It is going to be sin 2x cos x plus cos 2x sin x. At this place, didn't I tell you that you should write 1 minus 2 sin square x? Use the same logic here, no? Plus, what is the formula for cos 3x? Into what is sin 2x formula? Yes, then just multiply and then proceed. It will be 3 sin x minus 6 minus plus 8 sin power 5x. No. So in the expression, they have 16 sin power 5x. You will get it. And for sin cube x, you have 20. Right. So this part is completely in terms of sin. What are we supposed to do here? 4 into 2, 8. Cos cube x into cos x. So you have sin x into cos power 4x minus 3 into sin x into cos square x. So wherever you have cos raised to the power of an even number, what will you do? Write it as 1 minus sin square x. So the idea is cos power 4x, you'll write it as cos square x the whole square. And this cos square x, you'll write it as 1 minus sin square x, 10th standard identity. Cos square x plus sin square x is 1. This cos square x, how will you write it as? 1 minus sin square x the whole square. This part solve and tell me what are you getting. Do it fast. 8 times sin x into, so 8 times sin x into 1 minus sin square x the whole square minus 3 times sin x into 1 minus sin square x. So minus 3 sin x plus 3 sin cube x. Do it fast. When solve பண்றா ட்ரை ஆவது பண்ண யோசிச்சா வராது எழுதுனாதான் வரும் ரைட் your hand should go faster, the speed is not sufficient, your brain and hand should be in sync. Why are you thinking slow? Just focus, just focus and think that you can do it. So what are you going to get? You will get 8 sin x into 1 plus sin power 4x minus 2 sin square x, right? Minus 3 sin x plus 3 sin cube x. So what are you going to get from here? It will be 8 sin x plus 8 sin power 5x minus 16 sin cube x minus 3 sin x plus 3 sin cube x. This is only the second part. This whole thing is only the second part. So what is the first part? This thing. So 3 sin x should get added to minus 3 sin x and 8 sin x. So 3 sin x and minus 3 sin x get cancelled. What is that you're left out with? 8 sin x minus 6 sin cube x minus 4 sin cube x minus 10 sin cube x plus 3 minus 7 sin cube x minus 16. So what is expected? 20, huh? One minute. See, this is okay. There is a mistake here. It should be 6, no? 3 into 2, 6. Okay, that's not an issue. Here it will be 6 and here it will be 6. That's it. Okay, so this should be 6. And this should also be 6. Now I think we got it. So listen, 3 sin x plus 8 sin x is 11. 11 minus 6, 5. So that is the first term, 5 sin x. Minus 6 minus 4, minus 10. Minus 10 minus 16, minus 26. Minus 26 plus 6. Minus 20 sine cube x. Okay. Look for the coefficient of sine power 5x. 8 plus 8. That's it. Is that what they're expecting? That's the expression. That's what they asked. 5 sin x minus 20 sine cube x plus 16 sine power 5x. At least next time do it properly, okay? In your exam, if they ask sine 6x also, you should be in a position to do it. Maximum they'll ask till 6. Okay. Any other question? This tan 4 theta, I remember solving, it's a textbook problem. Sin 3x plus sin 2x minus sin x is a direct application of that sin c plus sin d formula. You need to apply it twice. Right. Okay. You need more practice. Are you guys doing the assignment properly? Weekends, are you sitting with the assignment that is being given? As one in the problem varad. Okay. Anyways. So I'm starting the next chapter, that is complex numbers. Okay. Principle of mathematical induction is not a part of your syllabus. So after trigonometric functions, we have complex numbers only. Okay. So the chapter we are going to start with is complex numbers. If you look at the name of it, right? The name is So if you look at it, this complex number has something to do with the counterpart of real numbers. Okay. So first, let's try to understand where do they come from. First, we will see the introduction of complex numbers. So the concept of complex number comes from the concept of quadratic equations. See, suppose I give you this equation of x square minus 5x plus 6 is equal to 0. I'm asking you to factorize it. Okay. So what will you do? You will first check the coefficient of x square, multiply that value with the constant. So for 6, you will try to find the factors. So in this case, what is going to be the factor? 1, 6, 2, 3, right? And you will check if these factors are adding up to give the middle term. So if you observe, the middle term is minus, right? So since it is minus, but the multiple is positive. So obviously what will happen? You need to have the sum of two negative numbers so that the product becomes positive. That's the logic you'll use, right? So here I can put a minus, here I can put a minus, here a minus, and here I'll put a minus. So minus 1, minus 6 is not matching. Minus 2, minus 3 is going to match. See, this is what you're going to do with factorization, right? But I'm not concerned about this. Is there a way we can say whether factors are going to exist for the given quadratic equation or not? So all that we need to do is, even before we start thinking about the factors of a multiple, what we need to check is a discriminant. So what does this discriminant speak about? It speaks about the concept of b square minus 4ac, right? B square minus 4ac, where the general equation for quadratic equation is ax square plus bx plus c is equal to 0. So it will be b square minus 4ac. So if this value comes out to be greater than 0, then what are the kinds of roots that you're going to have? You will have real and distinct roots. Similarly, if b square minus 4ac is equal to 0, you will have real and repeated roots. Or you will have the equal roots, both are same. Okay. If b square minus 4ac is less than 0, you will not have any real roots. So you will say you have no real roots, or can you say you have imaginary roots? So this concept of the discriminant being less than 0 and generating the imaginary roots gave rise to the concept of complex numbers. So basically, complex numbers are those numbers where you have a combination of a real and an imaginary part. Okay, let me explain what it means. Suppose I take this quadratic equation x square plus x plus 1, right? If I apply the formula and solve this equation, I'm going to have x is equal to minus b plus or minus root of b square minus 4ac divided by 2a, right? So what is the value of b here? It is 1. So minus 1 plus or minus root of b square, that is 1, minus 4 into what is the value of a? 1. And what is the value of b? That is also 1. The whole divided by 2 multiplied with the coefficient of x square is again going to be a 1. So I leave it as 2 itself. Now, the same x, how can I write it as? Can I write it as minus 1 plus or minus square root of negative of 3 divided by 2? So this negative square root of negative number is what is called as a imaginary number. So observe, square root of minus 3, can I write it as square root of 3 into square root of minus 1? Makes sense? Now, if I need to give a symbolic representation to this root of minus 1, you call that as I. So basically, square root of minus 3 is written as square root of 3 times I, where that I is square root of minus 1. You're able to understand? You're able to understand? So you will take this, and if you substitute it here, then this will become minus 1 by 2 plus or minus the square root of minus 3. How can I write it as root 3i divided by 2, where this x is going to be an imaginary root, or this is going to be real part. Why I call it as real part is because it is a fraction of two integers. It's a rational number. So it is the real part, and this one is the imaginary part, and this combination can be called as a complex number. So did you understand? Complex number comes from the concept of discriminants. From there only we borrow this idea. Okay. So it is going to be real part plus imaginary part. So to put it simple, complex numbers are represented by the symbol Z. How are they represented? With Z is equal to, you write it as A plus I times B, where this A can be called as RE of Z. So how do you read it? It's called as the real part of Z, and this IB can be called as IM of Z, which is the imaginary part of Z. And this is the general representation of a complex number. Is that clear? So please make a note of it. That's why if you see, the name of the chapter is what? Complex numbers and quadratic equations. Done. Shall I proceed? Yeah. So the next topic that we'll see is equality of complex numbers. Suppose I have two complex numbers Z1 and Z2. Right? If you have to say Z1 is equal to Z2, then Z1, if I consider it to be A1 plus I times B1, and Z2, I consider it to be A2 plus I times B2. If these two complex numbers are expected to be equal, then their real parts should be equal. That is, the real part of Z1 should be equal to the real part of Z2. Similarly, the imaginary part of Z1 should be equal to the imaginary part of Z2. So it is very much similar to the concept that we have seen in set chapter. Whenever we give two set, what will you do? You will compare the first terms and you will compare the second terms, no? So when the first term and the second term are equal in both the sets, we say that they're equal. Similar is the case for the complex number also. Only difference is the first number is called as the real part of Z1 and the second number is called as the imaginary part of Z. That is all you need to do. Okay, make a note of it. Just a disclaimer, this chapter is very, very easy. It's a very easy chapter. Natural. Sorry, literature plan. Equality of complex numbers. Right? Okay. So let's see an example based on this. Suppose they say x plus iy is equal to 2 plus 3i. Find x comma y. Answer is very simple. All that you need to do is, see, for the sake of steps, you need to write this as Z1, this as Z2. Then you need to say real part of Z1 is equal to real part of Z2. So comparing both the sides, what do you get? X is equal to 2 and y is equal to 3. That's it. It's simple. Right? Okay. So I hope this is over. No? Next is, we will see the concept of power of I. Right? Now, the concept is going to be power of I. The concept is power of I. We know that I is equal to square root of -1, right? So if I square on both the sides, we get I square. I square is equal to square root of -1, the whole square, which is going to be -1. Now the next question is, what is going to be the value of I cube? I cube will be I square into I. So let's take the combination of these two. I square is -1. I is I only. So -1 into I is going to be negative of I. Is that point clear? Okay. Similarly, what is going to be the value of I power 4? I power 4 will be equal to I square the whole square. I square is -1. So -1 the whole square is going to be +1. So basically, if you look at the cycle, I power 1 is going to be 1, I square is going to be -1, I cube is a minus I, and I power 4 is 1. Now the question is, what is going to be the value of I power 5? I power 5 can be written as I power 4 into I. How much is it? It is I power 4 into I, but I power 4 is 1, so it will be I. What about I power 6? It can be written as I power 4 into I square. So I power 4 into I square is -1. Similarly, I power 7 is going to be I power 4 into I cube. So I power 4 is 1. So I cube is minus I. Similarly, what is the value of I power 8? It is I power 4 the whole square, which is 1 the whole square, which is 1. So what is happening here? I power 5 is equal to 1. Sorry, I. And here also I power 1 is I. And I power 6 is going to be -1. I power 7 is minus I. I power 8 is 1. So if you break this and see, the first 4, is it not getting repeated? Similarly, what will happen if you start with I power 9? So I power 9 will again start with I. I power 10 is going to be -1. I power 11 is going to be minus I, and I power 12 is going to be 1. Okay. I hope this pattern is clear. So for every multiple of 4, so for the power being a multiple of 4, the pattern is getting repeated. Am I right? So having said this, okay. So having this in mind, suppose there is a question like this. There is a question like this. What is the value of I power 243? Okay. All that we need to do is, you will not sit and write the whole table. It's a waste of time. You saw the pattern. With that pattern, what logic are we going to use is, take the 243 and divide it with 4. Right? You remember Euclid's division lemma? Right? So you'll write 243 is equal to 4 times, what is the nearest multiple of 4? So it is going to be 60. So 4 into 60 is 240. So what is going to be the remainder? 3. So basically, this can be written as I power 4, the whole raised to the power 60. It's the same, no? I power 4 into 60 is I power 4 raised to the power 60. Into, what will you write? I cube. So basically, I'll explain what I wrote here is. Listen, I'll tell you. So listen. This, can I write it as I power 4 into 60 plus 3? So basically what I did is, if I'm dividing B with A, I wrote B is equal to A times Q plus R. I'm using the division lemma. Take that and write it here. This I power 4 into 60, can I write it as I power 4 into 60 into I cube? Right. So x power A plus B is x power A into x power B. Right. So this is going to be I power 4, the whole raised to the power 60 into I cube. Right. So this is how much? I power 4 is 1. 1 raised to the power 60 is 1 only. I cube is how much? You fall into the first bracket. So by you doing this, we are coming to this bracket. I cube is minus I. So all that you need to do is remember the first 4. So I cube is going to be minus I. So I power 243 is the same as minus I. Right. So to put it simple, any problem that you have, right? Any problem that is given, any number, for example, let's take the same number itself, I power 243. For the sake of marks, you need to show this step, but for you to find the value faster, all that you need to do is you need to write it as I power r, where r is the remainder. So I power r is going to be I cube, which is going to be minus I in this case. This is all you need to do. Okay. So having the same logic in mind, if I ask I power, tell me a number. 342. Okay. 342. What are we supposed to do? Divide it with 4. See what is the coefficient? Sorry, what is the quotient? It's going to be 85. So 85 plus the remainder is 2. So you will get the answer as I square, which is going to be minus 1. That's it. That is all you need to. So this is how the pattern for power of I keeps repeating itself. Okay. So this you can make a note of. You write the example also. Example, I hope you can do it on your own. You take whatever number you want. Proceed to the next class. I hope this gives you. The next concept is going to be algebra of complex numbers. As the name suggests, what do you mean by algebra here? You're basically going to add, subtract, multiply, and divide. Right. So when I talk about addition of complex numbers, let's say I have two numbers Z1 and Z2, for which we are performing the operation of Z1 plus Z2. Okay. So I'm going to fix the value of Z1 and Z2 for all the four algebraic operations we are going to see. So Z1, I'll call it as A1 plus I times B1, and Z2, I'll call it as A2 plus I times B2. Okay. So when I do Z1 plus Z2, I'm going to write it as A1 plus I times B1 plus A2 plus I times B2. So all that we need to do here is take the real parts, add them, take the imaginary parts, add them. That's it. So it is going to be A1 plus A2 plus I times B1 plus B2. So same is going to be the case for difference of complex numbers. So same is going to be the case for difference of complex numbers. So basically what will happen when I do Z1 minus Z2, it is going to be A1 plus I times B1 minus A2 plus I times B2. So what will you write it as? It will be A1 minus A2 plus I times B1 minus B2. That's it. Okay, these two are simple, no? Right? So in algebra of complex numbers, first we saw addition, second we saw difference. Okay, can make a note of this. Okay, shall I proceed? Now, the next question is about multiplication of two complex numbers. So here it is going to be Z1 into Z2. So what is the value of Z1 here? A1 plus I times B1 and Z2 is going to be A2 plus I times B2. So Z1 into Z2 will be basically A1 plus I times B1 into A2 plus I times B2. You have two terms here, two terms here. When multiplied, you will get four terms. Okay. So observe A1 into A2 is A1 A2 plus I into A1 B2 plus I into B1 A2 plus I into I is going to be I square into B1 B2. Am I clear with this? Clear with this? So this is going to be A1 A2 plus I into, can I write it as A1 B2 plus A1 B2 plus this thing, can I write it as A2 B1 plus A2 B1 plus I square is how much? Minus 1. So it will be minus of B1 B2. Reason? Since I square is equal to minus 1. That's the reason. Now, this is going to be the real part. That is A1 A2 minus B1 B2 plus I times A1 B2 plus A2 B1. So the four terms that you got actually get rearranged in this kind of a format where this is going to be the real part and this is going to be the imaginary part. Am I clear with this? So from this, can we conclude that whenever you are multiplying two complex numbers, right? Whenever you're multiplying two complex numbers, what is it you're going to get? You will get a complex number only, right? So here we can conclude that multiplication of two complex numbers gives a complex number. That's it. Okay. So this is how we basically do the multiplication. Make a note of. So you can write it on your own. Just a minute. Shall I proceed? Yeah. Okay. Listen to this. So multiplication of two complex numbers gives a complex number, is there, no? This statement is called as the closure law. It's called as the closure law. Okay, make a note of it. Done? No. So the next law that you can speak with respect to multiplication is commutative law. So when you talk about commutative law, if you take two complex numbers and multiply them, which is called as Z1 into Z2, the reverse is also correct, which is Z2 into Z1. So this is called as the commutative law. The next one is associative law, which is like Z1 into Z2 is multiplied first, and it is multiplied with Z3 is the same as multiplying Z1 with the product of Z2 and Z3. Okay. Is that point clear? Next. If you see, there is distributive law. So here what happens? Each complex number will be distributed to the other terms in the summation or difference. So if I have Z1 into Z2 plus Z3, then what will it be? It can be written as Z1 into Z2. Z1 is distributed to Z2 and Z1 is distributed to Z3 as well. This is called as the distributive law. Right. So I hope it is simple. Right. The next question is about two terms that I'm going to use now. Listen to this carefully. One is called as multiplicative identity, and the second is called as multiplicative inverse. Okay. So here, what do you mean by multiplicative identity? What is the multiplicative? What is additive identity in the first place? What is additive identity? What is additive identity and what is additive inverse? I'm asking a basic question. Let's forget about complex numbers. Let's talk about a real number. Let's say I have a number 5 in my hand. So if I ask you, what is the additive identity of this? What will you say? It is 0. Why is it called as additive identity? Because if you add a 0 to 5, you get back the same number which you gave as the input. Now the question is, what is the multiplicative inverse of this? So 5 multiplicative inverse is the reciprocal of it. It is 1 by 5, which is going to be 1. Okay, it's called as the multiplicative identity. It's not multiplicative inverse. It's called as a multiplicative identity. What is the meaning of it? When you take any number, when you multiply it with another number, right? So if I take a number and multiply that number with its multiplicative identity, it should generate a 1. Am I clear? Okay. I'm sorry, I actually made a mistake. It's multiplicative inverse. I'm sorry, my mistake. It's multiplicative inverse. This is 1 by 5 is multiplicative inverse. Okay. One is the multiplicative identity. So one is the multiplicative identity. Okay. So whenever you talk about an identity, I'll correct myself. Listen to this. Whenever you talk about an identity, right? When you add that number, it should give back the same number. In a similar way, when you multiply with that number, it should give back the same number. So if I take 5 and I multiply it with 1, what do I get? I get 5. So 1 is called as the multiplicative identity. Whereas if I take a number and multiply it with another number to generate a 1, that number with which I'm multiplying is called as a multiplicative inverse. Similarly, what is additive inverse? If I take a 5, if I add a number to it, it should generate a 0. So minus 5 is equal to 0. Minus 5 is called as the additive inverse. I hope you're able to understand this. In a similar way, extending the concept from real numbers to complex numbers, what will a multiplicative identity be? If Z is going to be the complex number, what should a multiplicative identity do? When I multiply the Z with a number, that should give me Z itself. So what is the number with which I need to multiply it? I need to multiply it with 1. Right. But the question is, you might get a doubt, sir, 1 is a real number. But remember, every real number can be expressed as a complex number. How you do that? You'll write it as 1 plus I into 0. So this 1 plus I into 0 is what is called as the multiplicative identity of Z, because it is going to give back Z itself. Right? Then what is multiplicative inverse? The reciprocal of it. So Z is there, no, not plus, it is multiplicative. So Z, if I multiply it with 1 by Z, then it is going to be 1. Then that 1 by Z is called as the multiplicative inverse. Is that point clear? Right? So make a note of it. Clear, Ada? Okay. These two are important. See, multiplicative identity, they'll not ask you a question. They'll give you a complex number and ask you to find the multiplicative inverse. It's very simple. I'll explain how to find it after I explain division. Okay. Okay. Listen. Shall I proceed? And the fourth algebraic operation we are going to do is division of complex numbers. So suppose I have Z1 divided by Z2. What is Z1 here? It is going to be A1 plus I times B1 divided by A2 plus I times B2. So if I have to divide a complex number with another complex number, the only thing I can do is take the help of multiplication. Okay. So the idea comes from the concept of how you deal with division of an irrational number with another irrational number. For example, I have 1 plus root 3 divided by, let's say I have 2 plus root 5. Okay. I want you to convert it into a form where the denominator is not irrational. So what will you do? I don't want the denominator to be irrational. So I will multiply with 2 minus root 5 and 2 minus root 5. Basically, this operation is called as rationalizing. So why do we call it as rationalizing? Because we are converting an irrational form to a rational form. Right. But what is the idea we took? Here you have 2 plus root 5, but what is that we multiplied with? We multiplied with 2 minus root 5. What is the 2 minus root 5 called as? It's called as the conjugate of the denominator. It's a conjugate of the irrational number that is there. So conjugate of 2 plus root 5 is 2 minus root 5. In a similar way, if I have A2 plus IB2, if I am able to multiply with A2 minus IB2 and compensate it with the same, then this A2 minus IB2 is called as the conjugate of A2 plus IB2. Okay. So A2 minus IB2 is called as the conjugate of A2 plus I times B2. Makes sense? Right. Now, all that you need to do is multiply the corresponding terms and see. So in the numerator, you're going to just multiply 2 terms into 2 terms. What are you going to get? You will get A1, A2 minus I times A1, B2 plus I times A2, B1 plus into minus minus I into I square, B1 into B2. I'll write it as this. The whole divided by, observe what will happen when you multiply a number with its conjugate. Listen to this. A plus B into A minus B format. So you will get A2 square minus B2 square, that is I times B2 the whole square. Okay. See, I times B2 the whole square is going to be equal to I square into B2 square, which is minus B2 square, because I square is minus 1. Right. So here, if you combine the terms, I square is minus 1, minus of minus plus. So what will you get? You will get A1, A2 plus B1, B2 plus I into A2, B1 minus A1, B2. A2, B1 minus A1, B2, the whole divided by A square I B2 the whole square is minus B2 square. So minus of minus. So this is going to be the division of one complex number with another. So this is a procedure that you need to follow, but you need not remember this like a formula. You can remember the procedure that we need to follow to solve when a question is asked based on division of a complex number with another complex number. Okay. Clear with this? Yes. So here I actually explained the other concept also, which is conjugate, which is actually dealt as a separate topic. Conjugate, just they'll tell you what is the conjugate of a complex number. Okay. So with this knowledge, you can actually solve the first exercise. Okay. So that should not take, there are actually 14 problems. But if you do it fast, right, it should not take more than 20 minutes. You can complete it. It's very simple. Okay. I'll do few problems and show you the remaining ones you think can keep solving it. Everybody has textbook with you? You have textbook or the study material, whichever you have. So I want you to read the initial questions alone. Yeah. So tell me, what is the first question? So before that, they would have given something, express something. Yeah, express each of the complex numbers in the form a plus ib, right? So exercise 4.1. That book it is 5.1. Yeah, exercise 4.1. The first problem is what? 5y minus 3 by 5y. Okay. So basically here 5 and 5 get cancelled. Right. So this will be minus 3 into I is I square. So I square is minus 1. So minus of minus will give you plus. Right. So how can you express this in the complex number form? You can write it as 3 plus I into 0. So it will be 3 plus I into 0. Okay. The second question is I power 9 plus I power 19. What is I power 9? When you divide 9 with 4, what is the remainder you're going to get? You will get 1. So I power 9 is I power 1. Plus, when you divide I power 19 with, you get I cube. So I power 1 is I and I cube is minus I minus I is going to be 0. So how will you express this in the form a plus ib? This you can write it as 0 plus I into 0. Clear with this? So third question is I power minus 39. So it is I power minus 39. This can I write it as 1 by I power 39? So when I divide 1 with, when I divide I power 39, where 39 is divided with 4, what is the remainder? So remainder is 1 by I cube. So this is going to be 1 by minus I, right? So can I say that this is looking similar to the division of complex numbers? So what you can do is, you just write I here and I here. So what will you get? I divided by minus I square. I square is minus 1. Minus of minus 1 is plus 1. So you're left out with I itself. So what is going to be the number? 0 plus I into 1 or 0 plus I. You can leave it like that also. Real part is 0. 0 plus I or I into 1, whichever is convenient. Okay. So hope it is simple. Shall I proceed? See, what is the fourth question? Here I have I7. I don't think it is I7. It is. Okay, got it. So the fourth question is 3 into 7 plus 7i. Basically, it is written as I into 7. So it is I in 7 plus 7i plus I into 7 plus 7i. So what you can do here is just multiply. It is going to be 21 plus 21i plus 7i plus 7 into I square. So what will you get? 21 plus 21i plus 7i is 28i minus 7. So 21 minus 7 is 14. You will write it as 14 plus 28i, or you can write it as 14 into 1 plus 2i. 14 into 1 plus 2i. Okay. Shall I proceed? Listen. Fifth one is 1 minus I minus of minus 1 plus 6i. 1 minus I minus of minus 1 plus 6i. So it is 1 minus I plus 1 minus 6i. So 1 plus 1, 2. It is going to be 2 minus 7i. Right? Sixth question is 1 by 5 plus 2i by 5 minus 4 plus 5i by 2. So 1 by 5 minus 4. it is minus 19 by 5. 1 by 5 minus 4 is minus 19 by 5 plus I into 2 by 5 minus 5 by 2. So 2 by 5 minus 5 by 2, it is going to be 4 minus 25, the whole divided by 10. So it will be minus correction. It will be minus 21 divided by 10. So I into minus 21 divided by 10. So it is of the form A plus IB. So seventh question is 1 by 3 plus 7i by 3 plus 4 plus I by 3 minus 4 by 3 plus I. Okay. So 1 by 3. So this is given within the square bracket. So 1 by 3 plus 4 is how much? 1 by 3 plus 4 is 13 by 3. 7i by 3 plus I by 3 is 8i by 3 minus, actually this is minus of minus, so it will become plus 4 by 3 minus I. I opened the bracket. So 13 by 3 plus 4 by 3. 17 by 3 plus 8 by 3 minus I. 8i by 3 minus I. It is going to be 5i by 3. So this is going to be the final answer. Where 7i? Done? No. So listen. The eighth one is 1 minus I the whole power 4. 1 minus I the whole power 4. So can I write it as 1 can I write it as 1 minus I the whole square? The whole square. So A minus B the whole square is A square plus B square minus 2AB. Right? This thing, the whole square. So 1 square is 1, I square is minus 1, minus 2 into 1 into I is 2I, the whole square. 1 and 1 get cancelled. Minus 2I the whole square is going to be 4I square, which is going to be minus 4. So the answer will be minus 4 plus I into 0. Minus 4 plus I into 0. That's what I did. This is A, this is B. No need. No. Basically, they are asking you to write it in the real plus imaginary part. Shall I proceed? The ninth question is 1 by 3 plus 3i the whole cube. So a plus b the whole cube. A plus b the whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. A cube 1 by 3 the whole cube, that is 1 by 27 plus 3i the whole cube. 3 cube is 27 into I cube. I'll write I cube with the next step. Plus 3a square b. So 1 by 3 the whole square is 1 by 9 into b is 3i plus 3ab square, that is 1 by 3 into b square, that is 9i square. Okay. So it is going to be 1 by 27. I cube is minus I. So it is minus 27i. 3 into 3 is 9. 9 and 9 will get cancelled. And here 3 and 3 get cancelled. So what is it you are going to have? 1 by 27 minus 27i plus I plus 9 into I square is minus 1. So minus 1 into plus is minus of how much? 9. So basically whenever you do these kind of operations, you will have two real parts, two imaginary parts. You need to add them. 1 by 27 minus 9. Whatever. Minus lower. See, 27 into 9. Actually 39 is 270. 270 minus 27. 243. 270 minus 40. 240 minus, 270 minus 27. 243. 243. Yeah. So this is minus 243 plus 1. Minus 243 plus 1 is minus 242 divided by 27. Minus 27i plus I is minus 26i. And this is going to be the answer. So this is A, this is B. Here with this? Shall I proceed? The 10th question is minus 2 minus I by 3 the whole cube. This minus 2 minus I by 3 the whole cube. What you can do is you can take the minus sign out so that it will become negative of 2 plus I by 3 the whole cube. So for this you can apply the A plus B the whole cube formula. So keep the minus sign outside. It is going to be 2 cube, which is 8 plus I cube by 3 cube. I cube is minus I. I cube is minus I divided by 3 cube is 27, right? Plus 3a square. A square is 4 into b plus 3a b square. That is I by 3 the whole square. Okay. So this whole thing within the bracket. So negative of 8 minus I by 27. Here 3 and 3 get cancelled. So you are left out with 4i. Here if you observe 3 into 2, 6. Actually you have 3 into 2 into I square is minus 1 the whole divided by 3. 3 and 3 will get cancelled. You will be left out with minus 2. So 8 minus 2 minus of 6 1 by 27 minus 4. Actually, it is minus 1 by 27 plus 4. 27 fourths is how much? So it's going to be 108. So 108 minus 1. It's going to be plus 107i, the whole divided by 27. So what is going to be the final answer? It will be minus 6 minus 107 divided by 27 times I. Is that clear? Is it easy? So we're almost at the end of this. Actually, the chapter itself is over. Next one, the miscellaneous problem, argon plane and everything. It's a very, very, very small chapter. They didn't give polar form, no? What did they say? Argon plane and its modulus. That's just 10 minutes concept. So by tomorrow we'll be completing it. So how many more are there? No, main problem I explain. One problem I'll explain, the multiplicative inverse. 4 more. I'll do one, the remaining you do it. Okay. So the first one in that set of 4. Listen. The 11th question is, find the multiplicative inverse of each of the complex numbers given in exercise 11 to 13. So the 11th question is 4 minus 3i. What are we supposed to find? We need to find the multiplicative inverse of this. So if I call this as z, multiplicative inverse of z is going to be 1 by z. So what I need to find is, I need to find what is the value of 1 by 4 minus 3i. So basically, it is division of two complex numbers. Rationalize it. 4 plus 3i divided by 4 plus 3i. So numerator is easy. It is just 4 plus 3i divided by, whenever you are multiplying a conjugate and the complex number, you just square the real part and imaginary part, add them. So here it is 4 square plus 3 square. 4 square plus 3 square. That's it. Just check what I did in division. When I multiplied a plus ib with a minus ib, what was the denominator? Division paper. Go and check the division. Did you write down for division? Check what is the denominator there. When you multiply a complex number with its conjugate, you get real part square plus imaginary part square. Okay. So it is 4 square plus 3 square. Answer will be 4 plus 3i divided by 25. 4 square is 16, 3 square is 9, 25. So answer will be 4 by 25 plus 3 by 25i. And this is going to be 1 by z, or you can call it as z inverse. It's called as a multiplicative inverse. Am I clear? Okay. So 12, 13, and 14, you guys solve and come. I'll start with that, and then I'll explain argon plane and polar representation. So after that, actually, there is no exercise based on it. It is directly miscellaneous problems. Okay. So as I told you, this chapter is very simple. So tomorrow we'll be completing it. Now you can close. Edra? Those are online, you could understand?
Yes.
Okay.
Yes, sir.
Good. So there are no questions, we'll wind up. You can leave this.
Thank you, sir.
Thank you, sir.
Yeah.